Hi, everyone. My name is Chris Bona. I look after stuff here at Google sometimes, and one of the things I look after is open source and also a little bit of our relationship with NASA, specifically over at Ames. And you know, when this talk was proposed, and I was just saying this to Jay, it's almost like it's a dog whistle that is like, okay, so open source mission control for Chrome. So space, open source, Google. So this is a really well-suited talk. I was wondering if you could work Android into it somehow, or you know, something like Kubernetes. But anyway, the long and short of it is, Jay is here from Ames to talk about his project.
You know, I like to be very interactive. If you guys have questions, please just go ahead and ask. You know, if you look at that topic list, open source, mission control, Chrome, any one of those could probably be its own talk. You know, so I try to get enough in there to at least seed the questions. And we'll go from there. I like to start with this because I think when people think of NASA, they usually think of Cape Canaveral or maybe Mission Control Houston. You guys are down the street from Ames, so you know about us. And of course, there's JPL, but there's really a lot of NASA all over the country. So I like to start with this, just give people a little bit of a perspective of what the centers are and what the geography looks like. So Mission Control obviously is for missions. And you know, what are we doing with these missions? We have a lot of discussions about human missions. We used to call it manned space flight, but we don't do that anymore. We call it human space flight. Or versus robotic space flight. And you know, how do we experience this? And I just want as background for this talk to think a little bit about that. You know, what is the mission experience? You know, if a person flies in space and it's not you, does that really enhance your experience of it? Maybe it does. Maybe you can kind of vicariously enjoy that. Versus a robot, which I think is a little bit less personal. On the other hand, the pictures don't really look any different whether they are from a robot or for a human. And of course, you know, robots, we can get robots much further out than we can get people at much lower cost. So I think there's going to continue to be a balance between these mission types. As far as mission control goes, I just wanted to get across the idea of one-way light time and round-trip light time because it completely bounds and affects how we operate. So if you look at that, the moon, round-trip light time from the moon, that's only a couple of seconds, but you add the latency in for the communications overhead, and you're probably looking at 6 seconds, maybe 10 seconds, maybe 25 seconds. It's not long, but if you're trying to joystick a rover on the moon, for example, that can actually be a very long time. If you're out at Mars, where you're looking at 20-minute, 48-minute round-trip light time, the idea of any kind of real-time command and control just goes out the window, right? So all of the films you may have seen of Apollo and the ground control interactions with the crew, that all goes away at Mars. By the time you get to Saturn and further out, forget it. I worked Voyager Neptune. I think we had a 4-hour one-way light time. So by the time we sent a command, it was 8 hours before we knew what happened. So that really impacts, obviously, the design of how we do missions and what we do where. So for crewed missions, we really have never gone past the moon, right? In most of you guys' lifetime, and from the time I was a little kid, we haven't been out of low Earth orbit. So you really do have real-time communication there, and you can decide how to allocate the jobs. So, you know, what would you think? You know, do you want to do it all in orbit? I mean, that would be the airplane model, right? You look at the space shuttle and you think about an airplane cockpit and you're doing everything on board. But if you look at the space station, a lot of the space station is actually flown from the ground, which may be counterintuitive. But we get into questions like, what is the value of astronaut time? What can we do most effectively where? I see somebody looking puzzled back there. So anyway, feel free to interrupt me if you have a question. The basic things we do in mission control, and you guys, so have you guys seen mission control on TV? When I say mission control, do you have an image in your mind, you know, of what one of these rooms looks like, maybe a sense of what we do? So a lot of it is system health and status, right? You can think of plumbers, electricians, you know, life support, all the people who just have to be the eyes and ears of the crew because you've got more data, you've got bigger screens. Think of the space station, I think it has 160,000 parameters. Pretty hard for a couple of crew members to monitor 160,000 parameters, or even a bunch of people on the ground. Planning, what are you going to do? You know, you've got this incredibly high value time. You've either got a crew or you've got a robotic asset. What am I doing with that time? Trajectory, which is where am I? Or where am I on the surface? And authority, who's in charge? Listen to tape of the moon landing and listen to those interchanges, and the ground could have called an abort. You wonder, and then read what the astronauts said about what they would have done in some of these instances, and it gets very interesting. But I think one of the things that comes with authority comes down to how much you can see. And we simply can see more on the ground than a crew can see, obviously, right? Bigger displays, more data, more eyes and ears. Okay. And conceptually, this is how we do it for robots, right? So my first thought was, well, I was going to put all from the ground, but then there is this sense of autonomy. We tend to be, I think, stingy and conservative when it comes to autonomy, probably with good reason, because when you get an asset up on Mars, for example, you're just going to be very conservative about how you operate it, at least at first. So really everything, obviously all the authority, command and control is done from the ground. There is no crew when you're talking about a robot. So this is, did you guys recognize this? This is the iconic mission control from Apollo. And I'm going to talk a little bit about what those consoles do versus how we do it now in a later slide. That's the newer version of the same control center. That's after Mars Science Lab. Now, why is everybody jumping up and down here and nobody's jumping up and down here? Now, I've read things in the media that would lead you to believe that it's just because these guys over here are boring and staid and old school, and these guys over here are modern and cool, and they're going to celebrate, and they're much looser, and they're wearing polo shirts, right? Whereas these guys are wearing suits and ties. This is where I started, by the way, so I've been one of those guys once upon a time wearing that coat and tie. I don't actually think that's the main reason. I think it gets back to my earlier slide, which is one-way light time, right? So here, you've got real-time command and control, okay? You are watching things. What you do has an immediate impact. Here, anything you do, you're not going to know what happened for 20 minutes. You've got a little bit more room for celebration. Now, part of it could be cultural. I'm just saying technically there are reasons why you will see people acting differently in different contexts like that. This is a science room. I took this picture, I think it was 2004, just before the first Mars exploration rover landing. Incredibly exciting. That's the engineering side for the Mars exploration rovers. That's the science side. I wanted to throw in one from down the street. That was for Laddie. And when we say mission control, though I'm going to talk a lot about this version because I've worked more in there than I have in the others, mission control takes a lot of different forms and has been evolving and is going to continue to evolve how we do it. So I wanted to have a little bit of fun because when I was a kid and a summer intern in mission control for the first time, all of a sudden I watched a Star Trek episode, and in my mind I started mapping who the characters were to the mission control position. So I won't tell you which version of Star Trek that was, but I'll tell you it wasn't any of the newer ones. That was a while ago. So we have a flight director, call sign flight, and that clearly is the captain, right? And then we have systems positions who are responsible for all the engineering. That would be Mr. Scott if you're in the old Star Trek. In the newer ones, I'm going to lose my way here. I think it was Geordi in The Next Generation. I don't remember who it was for Voyager or Deep Space Nine. You guys could help me out with that. And then navigation, right? That was Chekhov. Where are we? Okay. We have trajectory. It's called FIDO, Flight Dynamics. And then payloads, and a POC is Payload Operations Control Center. That tends to be where the science is. We've got a lot of scientists in back rooms doing science, interfacing with the flight control team. So that would be Spock, right? That would be the front room position. And then INCO for the shuttle was Integrated Communications Officer, and that would be Uhura. And you guys can help me out if you want to get to some of the newer Star Treks. I am dating myself here, I admit it. Okay, so I want to just go through a couple of calls from mission control so you get a better sense of how all these positions operate together.
Okay, all flight controllers, go for landing. Retro. Go. FIDO. Go. Guidance. Go. Control. Go. Telcom. Go. GNC. Go. Ecom. Go. Surgeon. Go. Capcom, we're go for landing. Altitude 4,200.
Houston, you're go for landing, over. Roger, understand, go for landing.
Does anybody recognize any of those voices? Any space historians in here? The flight director was Gene Kranz. Anybody who's seen Apollo 13 probably, yeah. And then the Capcom was Charlie Duke, and of course that was Buzz Aldrin in the lunar module while Neil Armstrong was flying. The point I want to make here is that was simply a nominal set of status calls. That's the, you have these predefined points where the flight director is going to give a go, no go, and then all the positions respond, hopefully, go. And they're very high adrenaline, very exciting, real time. And you can only do that when you're close enough to Earth for that to be meaningful. And by the time you get to Mars, a call like that will be very different. Okay, so that was a nominal. Let's look at an anomaly.
1201. 1201. Roger, 1201 alarm.
1201 alarm. Same type, we're go flight. Okay, we're go.
We're go. Same type, we're go.
You know, to me personally, this is probably my favorite call in mission control history. I think they were about 10,000 feet off the surface of the moon. I could be wrong. And there were a series of computer program alarms, meaning the computer was just overloaded. It was getting information faster than they could handle it. But picture Neil Armstrong flying this thing. We've never landed on the moon before, 10,000 feet. I hope I'm right about that. It could have been higher. And these alarms are coming in, and mission control is looking at them, and you're going to give a go, no-go call to land on the moon or not for the first time ever. You hear a go, and that's from the front room position. I believe that was Steve Bales, probably DPS, data processing, and probably 3 folks in the back room backing him up. So these guys in the front room you see, they have more eyes and ears in the back room. I believe they had trained to some of this, thank God, so they were able to make that call very quickly. To me, that, I mean, what a position to be in. You know, as a flight controller, I'd given anything to be in a position to make a call like that. And of course, those opportunities just don't come along very often. But
Okay, Houston, we've had a problem here.
Flight guidance.
Go guidance.
We've had a hardware restart. I don't know what it was.
Okay. Houston, we've had a problem. We've had a main B bus undervolt. You see an AC bus undervolt there, guidance? Or ECOM?
Negative flight.
I believe the crew reported it. We got a main B undervolt.
We may have had an instrumentation problem, flight.
so in a case like that, you are getting, you're on these little monochrome displays, and I'm going to show you an example of what these things look like. And you have a set of numbers, and you know what they're supposed to look like, and they are going crazy all over the place. And the flight controllers on the ground have to put this puzzle together and figure out what's going on. It is not like Star Trek, where Mr. Spock looks into his little sensor and the light shines out and he says, "This is exactly what's going on, Captain." It is not like that. And you're dealing with engineering schematics and sensors and trying to piece all this puzzle together to figure out what that means. In Apollo 13, that was a...
Lead copy, stand by. Flight Fido, abort ATO. Abort ATO. Challenger Houston, abort ATO.
Abort ATO.
So a little background on that, and then this is the last tape I have, but Space Shuttle ascent, Challenger, ATO is abort to orbit. A main engine had shut down. So 3 main engines, right? One of them has just shut down. Why has it shut down? That's question number 1. What do you do about it? So you heard the call FIDO in there, and I had mentioned FIDO. That's flight dynamics. So where are we? What's our speed? Where can we go? So they had an abort to orbit option on 2 engines, which they took. Turned out the engine had shut down because of a sensor problem. There was actually nothing wrong with the engine. There was also a sensor problem in another engine, and if they had lost 2 engines, it would have been real trouble. So Booster, and I think that was Jenny Howard, made what I think was a very gutsy and exciting call to inhibit those sensors, meaning if something really went wrong, you wouldn't have had the benefit of the sensors to shut that engine down. So there's risk involved in that. She made that call. The flight director says main engine limits to inhibit, tells the crew to do an abort to orbit, and they get into a lower but still functional orbit and had a successful mission. So, those are examples of the kinds of things you can do in real-time mission control. And it can be very cool stuff. Now, and those are highlight films, right? Every day is not a highlight film. Sometimes it's just the regular day-to-day stuff. But there are exciting moments. So the consoles, you guys are all into technology, right? So I thought you might find a little interesting what all these things do. And if you ever watch an old Apollo tape, these lights are always flashing. I was this little kid wondering what in the world those lights were doing and what the flashing was. I know most of you guys weren't born, okay, but I was a little kid at the time. Okay, so this is the old mission control, the iconic mission control. Monochrome displays, talking to IBM mainframes. No such thing as a personal computer. It wasn't even a glint in anybody's eye. These are for communications, as in you hear people talking, and by these buttons you can configure who you listen to and who you talk to. So the yellow lights, which are dimmer, are who you're listening to. The flashing white light is who you can talk to. And then there are blue lights, which could be either or. These are hard key sets, tactile feel, pretty cool. Audible click when you hit one of those buttons. And when I was a college student at Houston, I mean, these are the consoles we used. From Apollo to the Shuttle, they hadn't upgraded yet. So this was the stuff I trained on. Though I will say, I did not train on that, and I have no idea what those are. And I've asked several colleagues at Houston, and nobody knows what those are. So if any of you guys know, tell me. Okay, I'm going to do a close-up and get into these displays later, so I won't get into that in detail. Up here are, we call them digital display drivers or event lights. Think of a plastic overlay put in and a bunch of lights behind, and you program these lights, right? And they're just binary. They're either on or off, and you just program them with discrete values. Very simple, yet they worked. So I remember my first set of displays in mission control, once you did these things, you couldn't change them. And I got very clear instructions the first time I did this from my lead. He said, I'm not going to watch over you while you do this. They have to be right. If anything's wrong, after they hang me, I'm going to kill you. That was the only, so anyway, and the result of that is you put an astronomical amount of time into making sure these things are right, because you can't change them. So my displays had no problems, everything worked fine, but of all my status lights, one, I got my binaries reversed, and I had to spend this entire mission staring at this light that was on when it should have been off, and it drove me nuts. But anyway, just a personal story. These are pneumatic tubes. Literally, little P tubes. You can put a piece of paper or something in there and send it from one console to another. And you're sitting there on console and you hear this whoosh and bang and the thud. And this P tube's arrived and you open the door and you get your message out of the P tube. Those are used for hard copied information. Hard copied, can you guys imagine that, okay? I will say that other things, unofficial things, sometimes went through those P tubes, but I won't say what. Some of that may be online. So if you pop up to the newer consoles, they don't look that much different. I mean, okay, so you're running X windows here, and you've got a lot more display and application options. You are running plasma touchscreens for your voice loops instead of the tactile hard clicks. And to me, these were much more flexible and easier on your life between flights because you didn't have to decide exactly how to do the hard coding before. But these were much more fun and easy to push and use during flight. So that was a trade-off. But the basic operations mode hasn't changed much. It's just that the technology has been upgraded. So just quickly, people usually ask what I do at the end, so I throw it in here. I was a summer intern here. I was a college kid on those consoles, and that was just a hell of a lot of fun. So that was a couple weeks after the first space shuttle. I mean, the first space shuttle, imagine that. That was incredible.
You look like the guy from War Games.
Oh my God. Okay, I never thought of that. And here, so this was at Johnson Space Center. Here I moved to the Jet Propulsion Laboratory, but I was lead ops director for an Earth remote sensing radar that we flew on the shuttle about the size of a bus. And all I can say is it was a fantastic experience. We designed our payload ops control center. We did the hardware, we did the software. The radar was built at JPL. We flew it twice on Endeavour. And it was just, it was a lot of fun. Okay, so going back in time here, because I want to talk about display technology and applications and how we package this stuff for users. And I want to give you a little background so you can understand the mental model that we're dealing with here. And I understand this is a little bit hard to read, and I apologize for that. I need a better scan. This is how you specified a display. Okay, so this was Solar Max repair, the first satellite repair mission. We had George Nelson flying out literally in a Buck Rogers-style backpack to rendezvous with a satellite, bring that satellite back to the shuttle, put it in the payload bay. And I'm this college kid building displays for this, so I thought this was the coolest thing ever. And we built the same displays on the ground as we built for the crew, which we thought was a great leap forward at the time. Nobody would think twice about it then. In fact, we had a meeting with the crew. Bob Crippen, he was pilot from the first shuttle. Like I said, George Nelson, who was flying this manned maneuvering unit. And I'm this college student, and we're meeting with the crew, and I actually decided I was going to voice an opinion. And I couldn't quite get it out. And I remember all these astronauts kind of leaning in closer to try and hear what I was saying. Anyway, I'm not so shy now, but that was an awful lot of fun at the time. So on this grid, by hand, I would put in what I wanted, right? The labels and the little X's. And I'm going to show you what this display looked like. And then I had another sheet that would link a measurement identification number to a spot on the display. Can you imagine? This is called a scratch pad line. So the crew had this keyboard, and we on the ground could watch whatever they were entering into the keyboard. So we could see what they were doing. If it was in the software. If it was a hard-coded switch, we had to view it through telemetry and talkbacks. But I just want to give you guys an idea of how primitive this was. And it's the same type of technology we flew to the moon with. And I have to say it worked. I mean, it worked, right? We got to the moon. We flew the space shuttle. That is what that display actually looked like in hard copy. And we had a little button in mission control. And if we wanted to take a record of something, we hit a hard copy button. And I think this thing came through the P-tube. I'm trying to remember that. Time zones, GMT, and then mission elapsed time. So think about it, you're going to train for a series of mission events, but if you do those to an absolute time and you launch late, the whole thing goes out the window, right? So mission elapsed time starts at engine ignition and goes from there. It's a relative time. And this is a display for the flight control system, or the flight support system, which is when the satellite was brought back in, it was put in the flight support system to be repaired. Now, I know you guys are used to all these little touch screens from Star Trek and stuff. And by the way, according to what I've read, I wasn't there. Those touch screens were done because of budget limitations, right? Now, touch screens seem to be the direction we're headed. There's a panel from the shuttle. Simple toggle displays with mechanical talkbacks. But, it all worked. Can we read this? You guys can't read that. Sorry about that. I was trying to give you an idea of how we did timelines. Mission elapsed time, key event, and then roles for different, mission control, payload ops control center. That was in Washington, D.C. They controlled the satellite, and we were responsible for the shuttle. Okay. So that's the old mission control, and I want to talk a little bit about evolution. And you will get a lot of folks saying, well, why change it at all? Because the current model works, and I think that's a legitimate question. It does get hard to just keep technology standing still, though. So maybe you guys will have some perspectives on that you can share with me as we get towards the end here. I will say that when you get a group of people who want to create change, you will get a certain friction from those who resist it. I don't find that to be unique to NASA. And occasionally I find myself having more sympathy for that group as I get an upgrade to a piece of software I use that I think changes everything around for no perceivable benefit. So maybe I'm just getting crotchety as we go. I don't know. Like I said, share a perspective with me on that when we get to the Q&A part or any time. I do think that software built as applications creates a set of walls. So if I'm using Photoshop or Painter, or any of these other tools, and they're all good tools, and I can't mix and match my tools, right? I really have to take the whole package. And we have the same issue with our software, right? Or a word processor. I could be using Google stuff, or I could be using Apple stuff, or Microsoft. There's all kinds of choices here, and they're all a package set. Duplication, a few years ago I counted the drawing tools on one of my older computers. 10 sets of drawing tools that did pretty much the same thing. And then, of course, you get software bloat, right? You just keep adding features. In the commercial world, it's very hard to take a feature away because any feature someone has gotten used to, and you can take some obscure feature away, and somebody somewhere is going to have an absolute fit. And it's the same thing here. I mean, who successfully takes features away? Apple does it, and people make noise, and they do it. So it's very hard for us to do that internally. So open source, and I'm going to come back to open source later also. We've had a couple of efforts here. A desktop effort called Mission Control Technologies, which is on GitHub, and I put the URL in there, and it looks like in blue against black you can't read it. But if you search for NASA MCT GitHub, you would find it. And that's been our first effort, and it was done in Java. And we are moving to a set of web-based tools now called Warp. And that's in the queue to be open source. And I hope that's out there in the world in a couple of months. And I believe that is the direction we're headed. I'll show these URLs again at the end. And of course, I would love people's feedback. So, why do we open source stuff? Because open source does take some effort, right? You have to go through the legal approval. If you're going to have any sort of success, you have to support the community. You guys have more experience with this than we do. So why do it? Well, there's a couple of ideas. One, for collaboration, we used to go to somebody, even internally, but certainly externally with our software and say, hey, we've got this cool software, why don't you use it? And they'd say, okay, can we download it? And I would say, sure. Let me get a legal agreement together, our lawyers, your lawyers, and maybe in a couple of months you could try the software. How do you think that worked out? You guessed it, it didn't, okay? So open source, that conversation is great. Go to GitHub, you can have it right now. So it's the immediate enabler for collaboration. I think with ground system technology, this is just me, we should share that. Really, the focus of space flight is on the flight systems, and we should be getting these ground systems out there so anybody can use them, just my opinion. I would love to think that we can build a community of people open sourcing ground systems so that it's not novel anymore. And there's always this chance, maybe we can put it out there, innovation out to the outside, and we will get something that we had never thought of. Okay, so think about what I was showing you earlier. There was no concept of an application, a widget. We were simply looking at displays. I don't think we cared about the software. I don't think we thought about it. We've evolved to applications. I want to move us to objects and compositions, and I don't think people will understand that. And I'll show you some pictures of what that means. But anyway, depending on, everybody has a different mental model. To a flight controller, you're just looking at displays. And what are you doing when you're doing Google Apps, right? Are you looking at apps? Are you looking at objects within apps? It really depends. It depends on your mental model. So if you get a software-ish flight controller, you can talk this language. Otherwise, they're not that interested. Also, I think more and more, we get into these sandboxes, okay? So, in a mission, I just want people to be able to get to their information. That's what you want to do, okay? And as an analog, you don't want to be there in a mission saying, wow, is it in Dropbox? Is it in Google Drive? Maybe it's in iCloud. All these sandboxes we're creating, and there's reasons for creating those sandboxes, right? Some of it is security. But I just find constantly, I'm having to scratch my head and saying, wow, did I put that in my encrypted image on Google Drive? Is it local on my desktop? I mean, imagine putting something local on your desktop, but people still do it. So anyway, how we chunk this stuff, how we get at it, is all a set of issues. So let's see if I can make this, oh man, you can't read that too well. Let's try and make this moderately comprehensible, okay? So here's the old stuff that I show you, right? And the mental model is displays. And those displays are on channels. So I have a DTE guide. It was called a Digital Television Equipment Guide. I think it had 73 channels. And I have to look at that, and I'm going to go to this little channel selector, right? And I'm going to move my little dials, and I'm going to select a channel. I've got 3 monitors. I hit a button, I get a hard click, and it appears, okay? Now, otherwise, next model, applications. Do you notice anything about these applications? Do they look somewhat heterogeneous? I think they do, okay? Lack of consistency. Now, that happens in industry too, right? I mean, I know at Google a few years ago versus now, there's been a big drive to create design unity, bring things together, material design, all this stuff. And as a user, I'll tell you that shows. I can tell things seem much more unified now. But when you're here, which we were a few years ago, that's an issue. So the idea here is to, where we can, move into an objects and composition model that does not force you to think about applications and allows you to think more just about what you are doing. And of course, that's an ideal. And it will work in some instances, and in other instances it won't. But it is one direction in which we're headed. And I hope that makes sense. Okay, history lesson for you guys. So how many people have heard of Xerox Star? Wow, just a couple of you guys, huh? How about OpenDoc, Apple and IBM? Well, I know you guys, Okay, interesting. All right, so if you go back to the history of where all this stuff came from, The Xerox Star was one of the first commercial GUIs. I know you guys all know about Xerox PARC and the famous demos and how the GUI came about. But if you look back to this, there wasn't so much this idea of applications. There was this idea of objects, right? Inbox, outbox, documents, printers. Instead of applications, you were interacting with objects. You didn't have this sense that I was going to go to Google Drive or Google Docs or Google Sheets. You were just interacting with objects. OpenDoc was, the idea here is you have a container and you put parts into that container, and each of those parts has editors. So instead of a word processor, I have a word processing part or a spreadsheet part, and I can mix and match and create various compositions. I don't know that these things failed for technical reasons, but and I'm not going to try and analyze that. That would be outside the scope of what I'm saying here. But there's some very interesting ideas that got left in the cutting room floor as we move to the application model that we're all pretty familiar with. So in dealing with information, right, we have models and we have views, and we have different ways of looking at the same thing. So our idea, which I'm going to show you, is to provide a unified environment to do that. But I'm just giving you an example of my calendar, my ever so exciting calendar. Right? That is on my Mac, desktop application, Apple's calendar application. Does that look familiar? That's Google. Okay? But it's the same info, but it looks very different. Also the same info on my iPhone. Also on my iPhone, but a different application. And my point is, I'm basically doing Model View Control, or MVC, by using different applications to connect to my model. And I want to see these things in different ways, and I'm literally using a different app to get my different views. I'm not saying that's a bad thing. It's just one way to do it in a commercial market. Does that look familiar to you guys? So here, at least for me, when I'm in Google Drive, I feel like I'm going to find my stuff. I'm going to find my document or my spreadsheet or my image, right? I'm not thinking applications. I'm really thinking of what I want to do. Whereas here, this is Google Docs on the iPad. Right there, I'm only going to see one view of my documents. And I'm really starting with the application first. So where do I go? Do I go to the application or do I go to the data? And the answer is we're going to be able to do both. There's no one right answer to this, of course. So our approach, and some of this stuff may look, you can see where we got some of this inspiration from. It might look moderately familiar. But we just put all our objects in one environment. And this is new. This is the stuff that's going to be open source shortly. It's our web-based version of Mission Control. Just the visualization. I don't mean to imply it's all of Mission Control. It's a slice of it. We have a lot of discussion about which browser to use. And our answer to that is that we will develop and test it in Chrome. We are not doing anything to preclude it running in other browsers yet. Okay? There is discussion as to whether to use Chrome-specific things. But so far, we do all our testing and all our development in Chrome. And I'll leave it at that. So all your stuff is in here. There's no sense of different applications. I find something, I look at it, and I look at it through different views, right? That's my model view controller. So this is just simply a plot. But the point I want to get across here is everything is in one place. These are the ideas, right? No applications. You've got objects and compositions. I can look at the same thing in many different ways, in many different places. And in a second, I'm going to tell you about one of the reasons why I want to do that. So that is the same information. You're just looking at it in different views. You've just got a little pull down here, and I can look at the same thing in different ways. So why do I give a hoot? So here's a mission example. This is for scientists. And I'm sorry, when I took these pictures, I really never intended these to be close-ups. These are actually pictures from a room, and I just grabbed them. But the point is, right, that's a PowerPoint representation of a timeline. That's actually a sequential set of events, as is that for scientists, for engineers. But the point is, I want to see all these things in different ways. And what you get in a mission standpoint potentially is disconnect. So I've been in rooms where I've heard, say, a power number or a power constraint, and actually people had given different numbers in 2 different rooms. We don't want that, okay? So we want everything to be a display of the same underlying data. Okay, so examples here. And once again, I don't know how much you guys want to get into software or mission control or open source. And, you know, I don't mind you guys steering me in one direction or another. This, when you demo it live, is actually pretty cool. So that's a notebook, okay? Unremarkable. I'm sitting in a console and I'm saying, okay, at mission elapsed time such and such, the following thing happened, and I'm writing my notes or I'm typing my notes. So what this does for you is it timestamps it for you. You put your notes in. And even more cool, I can embed the live data into the notebook because I've got this composition model instead of an application model. I just take my data and I embed it in the notebook, and that is a huge advantage. Instead of referencing something or hyperlinking something, I've just got the actual data there, okay? Even more cool, I can take this notebook and say, you know what, I want to see my notebook in a timeline view, and there's my timeline view. And then I'm going to put my plotted data next to it. And now I can start doing all kinds of cool things just because I have models, views, and compositions. And I will admit this is not software I would give to my mother, but what we do, it's good stuff. Okay, and here I'm just trying to show more to data types. There's the timeline you saw earlier, another timeline, orbits, plotted telemetry, my point being that we can put all this stuff together. And it's very hard to design this stuff ahead of time and get it right. You know, what we find is we sit down and we say, here's what we think we need, and we build it and we start simulations. And those simulations typically start about a year before launch, and it's in simulations where you learn what you really want to do, right? And what would you guys do? You might do a Wizard of Oz walkthrough, or you might do a paper prototype, and there's a number of things you can do. But in this domain, it's very hard until we start doing simulations to realize what we really want. So this kind of flexibility in design is quite helpful.
Is your timeline view that you're showing there, that's just driven off of the notebook that you created after the fact or in real time?
Create the notebook in real time.
And then do you have timeline views that you sort of create beforehand? Or?
Oh, absolutely. Yeah. Now the ideal, and we haven't done this yet, but we're working towards it in the web version, right, is to be able to compare the predicted to the actuals and overlay all this stuff. We're not there yet, but that's the hope. Yes?
Are you going towards a direction where you could potentially change the composition during emission?
So, very interesting question. Technically, yes, that would be easy to do. Operationally, you would need a set of constraints to keep that under control, right? Because you are training to a particular layout and a particular composition, and I would be very careful about how I allow changes during a mission. I don't think, you know, from a mission ops perspective, me personally, creating a new composition, fine. Changing an existing composition that I had worked to, I would be a little bit concerned about. Right? I mean, think about flying in an airplane, you know, and you wouldn't want the pilots rearranging things. I wouldn't. Okay. So quickly, I'm going to use an example. This is a mission in the early design phase. It's called Resource Prospector. Got that nice short one-way light time. Lunar rover to explore for volatiles at the poles. And this is just a vision of how to put this together. You know, and I drew this out about a week ago, and I said, my God, it looks like iGoogle. You know, are we just doing widgets here? And you guys stopped iGoogle. And then I started asking myself, well, what's the difference between this and a set of widgets? Well, interesting question. I mean, to me, in my mind, these are not widgets, right? This is the actual procedure viewer and the procedure editor, and those are the timelines. And, but when you put them together and compose them into an integrated display, they do look somewhat like widgets. So I'll put that out there. And this is the first demoable prototype of that display. It doesn't have everything. Some of it's real, some of it's not. That's just a picture. That's from another piece of software called XGDS. But this is all in our software called Warp, Web Applications for Resource Prospector, so named by our lead developer, Victor Woltgen, who's sitting in the back of the room. So, of course, we are going to have to drive the rover, and each one of these components is called Warp, right? Warp viewer, Warp image. So, of course, we will have Warp drive. I think we named it Warp before we figured out that we were going to have Warp drive. But this shows the basic concepts, right? I've got a timeline, I've got all these mixed data types, and I can view the same data in different ways. And I can put that all together into a composition. And And so we had done that on the desktop in Java, and now we're doing it on the web, and we're pretty excited about that. And of course, we will try to take that to the tablet next, and then to the phone. So here's just a little bit of a close-up of the timeline. You can see what we're doing here. We're using this for design. So we're mapping out the traverses we want to do, and then we just map power and data. And then we go back and say, okay, we have a certain allocation for power and data. Can we do it within what we have? Do we try and push the design of the system to have more power? And we can answer questions like, for a certain size battery on the rover, what kind of emission can we get out of it? So we're using that timeline for design at this point. And you can see up here, you've got the pull downs. We've got an edit mode here. And everything is over here. And that create button, you guys know the story because you've got similar stuff. Plots, I think I've already shown that. So I'm not going to spend much time there as I'm getting towards my 40-minute time limit here. This is the notebook, the same idea as the notebook you saw, except web-based. I get timestamps, I get my notes, and I get to embed information in this. So just a couple more slides here. So as I said,
Do you have like a raw telemetry number view type?
well, in this software, you mean raw as in like, pulse code modulation counts, for example? The straight data value, do we have that? Victor's nodding his head yes, so I guess we have that. Most people, so here what people want to see varies. If you have a long program, you have flight controllers who are really thinking operationally versus the guys who built it who want to see, right, maybe things in more detail. Okay, so this, as I said, is on GitHub. I hope you guys can read that. That's the Java desktop version. I wish I could sit here and tell you that the web version is open source. I think it's very close, but it's not quite there yet. And I believe that's all I have. This is our info site. And if you check back in a couple of months, you might find the web version.
Since it's browser-based, any openness to potentially allowing people to create their own composition on view-only data to follow a Mars mission from the public?
So I would love it if stuff like that happened. And our goal is to get this stuff out there. It's on GitHub and say you can do anything you want with this. The key to that would be that we'd have to make some of that data available, which is something we will definitely explore. And then, to take it back, so anybody can put anything on GitHub once we've got it out there, right? So that would be completely unrestricted. My hope is also that there will be brilliant ideas, things we had never thought of that we can take back and actually use for missions. And I see little inklings of that, right? We've had contributors for our Java version. Some of them have just been our own folks that have left and kept using it, but then, some guy pops up from France and all of a sudden he's writing code. If we're going to use it in a NASA distribution, we have to do the paperwork and get permission from the developer to do that, but folks can put anything they want out on GitHub. And yeah, I'm hoping that when we get a web version out there that it stimulates a bit of an open source community and people become interested.
You said that you run these simulations like 6 months ahead of time.
Usually about a year.
So you have some idea of what the process of the mission is going to be like and what the data coming in from your sensors is going to be like at different stages of the mission. And you're watching that, and then you're making decisions based on when you see the data get to a certain point, right?
Correct.
You're like, I'm deciding at this moment I'm going to turn something on. Is there a temptation to automate that? It's like, when I see the sensors in this state, I want to automatically make this decision that I've pre-verified?
I will give you one example because it came up recently. For the Moon rover, the question was asked, do we want to be able to automate the prospecting decisions? So, we are driving, we are with the spectrometers looking for water. Depending on that data, do we want to be able to automate the decision? And my answer to this is, which validated with the science team, is we won't know in the short duration of our mission how to interpret that data well enough to automate it. If we had a mission that was going to go for 6 months or a year, I would say absolutely.
So once you've verified what your decisions are on the expected normal pathway, it seems like you've already automated it, but you're just waiting on a human to actually push the button.
Yeah, we haven't done much on now. I can't speak for all of NASA, right? I can only speak for the little slice that I know. I haven't seen a lot of automation. I have heard some discussion, and I think with system values, that might be an easier thing to do than with science data interpretation. And
Yeah.
what I was talking about was science data interpretation. You know, you have certain limits, right, for a subsystem, and you know how that's going to behave. But think of the example I gave you earlier for that abort to orbit for the space shuttle. I just don't think anybody would have, I don't think we're there yet for automating something that complicated where human life is at risk. And the answer is these conversations will be ongoing.
Could you maybe speak to the limits of some of these values coming in and how it displays to the screen and the operator's views?
So I'm going to start with those old monochrome displays. You had a little arrow, and it was called out of limits high, out of limits low, right? And then you had another indication for off scale, meaning it was out of the scale of the sensor. And then we used to use that in the office, right? If somebody was nuts, we'd say they're off scale high. But now with all the flexibility we have, you can design green, yellow, red, really any kind of indication that you want, as long as you know what that means. But you have for any subsystem an acceptable, right, like for your computer, you have an operational temperature range for your computer, you have a storage temperature range, it's the same idea. And then it's just a matter of how to indicate that on a display, and then, you know, some sense of what you will do that you've discussed ahead of time if something's not what you expect.
So this is mission control, not like flight drivers, obviously, but I imagine there's still some sort of risk involved in opening this up to open source, right? If something is bad, I mean, we've all had experiences, I think, with open source software where something was not done well or correctly, and this can potentially be a risk. So I just wonder what kind of like further process there is to mitigate that risk.
So I've been asked that question internally a lot. And the answer is right now, it's been mostly one way, right? It's been us putting stuff out into the world. There's been very little input path back. Most of the input path back has been from people who've left us and kept working on that software. So it's been a very tightly bounded problem. Then we've had just a couple of other people who've made inputs, but we haven't incorporated that. So I think the answer is so far we've been able to duck the question. If this were to actually take off, then we'd have to have a process for, you know, not only what you said, but deciding, you know, which design do we like? How much of this can we take? And, you know, I hope we are in the position of having to deal with that, but we really haven't yet. I'll probably be calling Chris and asking him how to handle that when the time comes. And I thank you for volunteering, Chris, to help with that.
That's what I'm here for.
The open source part of this, is it just the front end UI, or is there a back end component to this as well?
So far, it is the front end stuff. And open sourcing these things just takes a while. We will get more out there, and my hope is to get everything out there. But right now, it's all the front end visualization stuff. There's a lot of enthusiasm. When you mention open source, there's a lot of teams who would like to open source their stuff.
What feeds it right now, currently? Where is the bridge?
Where are we getting our data?
Like what would, if you were to pick this up as an open source, how would you feed it?
I'm going to let Victor handle that one. This is why he's here, and he wrote some of these data adapters.
Generally speaking, the front end is plugin based. So a category of plugin you can introduce to the front end, and that's the code that runs in the browser, is a connector to a data backend. So the expectation would just be that whatever the data source it has, or whatever data source you're integrating with, you either have or create some kind of web service to expose that data, and then present that data internally in the format that the application understands.
So with the move to a purely web-based thing, you gain a lot of the flexibility, but you lose some of the sort of tactile, physical stuff, like when you're talking about, you know, pressing the buttons for who to talk to. I can imagine sometimes on a web interface, if you're using like a mouse or a touchscreen, you might misclick on something, and it's a lot easier to click on something incorrectly than to, you know, depress a button that has some resistance incorrectly. So do you worry about, or do you have plans for breaking some of the stuff into more physical, tactile feedback, or is that an issue that you encounter?
At the moment, we have a whole separate system for the voice loops, right? So going to a web-based system, we're really taking things that have moved to desktop applications already and just putting them into web-based applications. We're not doing things like the voice loops. And we lost that tactile feedback years ago when we moved from, you know, those hard click displays to the touchscreen displays. So I think people are used to that. But the voice loops are a separate system right now.
You talked about kind of the heritage coming from mission control. I'm wondering if there are other domains where you think the open source project might be useful in, and if you've drawn inspiration from other domains into this, so like Bloomberg terminals or logs analysis interfaces, other kinds of like real-time things? Or do you think that this is going to always live in a world of mission control and maybe the ESA wants it?
Oh, I think the more we can interact with the world and draw inspirations like what you're talking about, the better off we are. So do we look at these things? Yes. Do we look at them as much as I'd like to? Probably not, but we definitely look at, we look at financial plotting applications, for example, to compare them to what we're doing. I think the data rates, and I don't know much about financial plotting applications, but, especially during launch prep, we're blasting pretty high data rates, and I don't know that financials need to be updated multiple times a second. But we certainly do look at those things. And it is my hope that through open source, we can start to get some of that two-way conversation. I hope that people will find our things useful in other domains and that we will cross-pollinate with other domains. That's part of the goal. We're just in the very, very early stages of it right now. So the question was, is there a command interface for this? And the answer is not yet, because it is the single most sensitive thing that we do. If people are so sensitive about their commanding, I think the idea in open source is we would let them build their own. We may, for some of our own missions, build a command interface, or we may use an existing one, but it will be the last thing we do because of the sensitivity of it.
Well, thank you so much for coming. It's really great to have you. So.